Hello and welcome to this video lesson. The focus of this video is slope of parallel and perpendicular lines. I often get my students started with this activity, and it's in two parts. So the first part says the following three lines are parallel. Use 2 points from two of the lines to calculate their slope, hence outline the pattern between the slope of parallel lines. So reading the question carefully, it says use 2 points from two of the lines, so we don't have to do it for all of the three lines. And to calculate the slope, so when we say calculate, we have to show all the steps. And then it says hence, so then we have to use the answer we got to outline, to give an idea about the pattern between the slopes. So let's start that. I'm going to use the red line and I'm going to use the purple line for this purpose, and I am going to choose two random points in here. It's really easy to use points which have one of their coordinates as in of value 0. So this one has coordinates of 0, 4, and this one has coordinates of 6, 6. And I will just choose points on my purple line as well. I'll use this one over here, which has coordinate of 0, -1, and I will use this one, which has a coordinate of 3, 0. Just to make things a little bit easier, especially if you're not using color pens, I'm going to label this line as A, and to find the slope, I will signify its slope with letter M and subscript A for slope of line A is equal to delta Y over delta X. You folks forgot what that is. Delta Y is Y2 minus Y1 over X2 minus X1. And what I will also do is I will label this as x1, y1, and x2, y2. So y2 is 6, y1 is 4, x2 is 6, and x1 is 0. So I get 2 over 6, which is simplified to 1 over 3 as my slope of line A. Now, it doesn't really matter which point you use, you should get the same slope value here. You could have chosen a point here, you could have chosen a point here. It really doesn't matter. You just need to make sure you choose a point which lies on the coordinate system, and try not to do an estimation of 1 over 3 or anything along those lines. Just choose ones that are actually on the coordinate system. For the purple line, my slope of, let's call this line B, is equal to, again, delta Y over delta X. Let's label some of my points x1, y1, x2, y2. So change in y is, y2 is 0 minus, and y1 is -1, divided by x2, which is 3, minus x1, which is 0. This turns into a plus, and we get 1 over 3. So slope of line B, we can see that it's 1 over 3. To conclude, we can see that both of these have the same slope. So we can make a concluding sentence that for parallel lines, slopes are equal. So in this case, mathematically, MA is equal to MB. And let's see if this makes sense. So in line A, you can see that the slope signifies the direction and steepness of the line. We can see that as independent is increasing, dependent is also increasing, so it's a positive slope. I'm getting a positive slope, which makes sense. The steepness, it's not super steep. I get a fraction of 1 over 3. Usually numbers which are smaller than 1 or between 0 and 1 are usually smaller slope, and usually anything larger than 1 usually has a larger slope. So I don't have much of a slope over here, so you can see that the steepness isn't much, and you can see the steepness actually doesn't change for parallel lines because they are parallel and they are always the same distance apart. So it makes sense that their steepness is exactly the same and their direction is also exactly the same, positive in this case. The second activity says the following two lines are perpendicular, and it says to use 2 points from each line to calculate the gradient and hence outline the pattern between the gradients of perpendicular lines. So reading the question again carefully, use 2 points, so I have to pick 2 points from each line, so we can do that, and then we can calculate the gradient and hence, so hence means use the information from previous work to outline the pattern between the gradient. So you can pause the video and try this out. It's actually a good practice for calculating slope, and then we can take it up. Alright, I'm going to label this line as A and this line as B, and I'm going to choose 2 points, one of them right here. Let's call this 0, 4, and any other points will do. Let's try a more challenging point, something that has some negative values in it, so 2 and -2 over here. So this would be my x1, y1, x2, y2. It doesn't really matter how you label things. It should, at the end, give you the exact same slope. So to find slope of line A, the equation is delta y over delta x. So I have -2, which is my y2, minus 4, which is my y1, over x2, which is 2, minus 0, which is x1. And I will end up getting -6 over 2, which is simplified to -3. And I will box my answer. For the blue line, I am going to choose 2 points. Let's choose this one over here, which is 3, 0. And let's choose this point over here, which is -3, -2. I will label this as x1, y1, and x2, y2. And the slope of B will be, again, delta y over delta x. And my y2 is 0, my y1 is -2, my my x2 is 3, and my x1 is -3. This turns into plus 3 plus 3, so I get 2 over 6, which is same as 1 over 3 when it's simplified. Okay, let's see if we notice anything between these numbers. So first of all, slope of MA is -3, slope of B is 1 over 3. We can see that they both share a 3. And we can see that if I were to write this one as -3 over 1, because those are the exact same thing, we can see that the 1 and the 3 here have flipped to give me this, or the 3 and 1 here have been switched to give me this. And we can also see that this one is negative and this one is positive. So writing this in a descriptive way, we can say that slope of line B is, first of all, we know that it's if this one is negative, this one is positive, or if this one is positive, this one is negative. So we know that there's a negative relationship is negative. And the other thing that we notice is that the 3 and the 1 switched, and mathematically we call that the reciprocal. Reciprocal of line A. And mathematically, the way we can write that is MB is negative reciprocal, so just 1 over MA of, line A. So negative reciprocal of line A. Now, the other thing we need to really understand is why is that the case? So first thing, when we look at two lines that are perpendicular, you can see that if one has a positive slope, or if one has a positive correlation, if something is perpendicular to it, it will automatically have a negative relationship. And that's where the negative here is coming from. And you need to understand that really well. Again, it's because if one line is positive, the other one automatically, if anything is perpendicular to it, it will automatically have a negative slope. And you can actually rotate these two in any direction and the same pattern will exist. If one is positive, the other one for sure will be negative. The other part is the reciprocal part. Notice that this line over here, which is the red one, actually the magnitude of the slope, or just the value of the slope here, is 3. And 3 is actually a pretty steep line. And if you take its reciprocal, whenever you take a large value and when you take its reciprocal, you actually get a very small value. And it makes sense because if you have two perpendicular line, if one of them has a very steep slope, the other one will automatically have a very, very, very small slope. So again, if one has a high steepness, the other one will have a low steepness. And the reciprocal part of the relationship will tell you that one has steep slope and one has a more shallow slope. To summarize everything, we know that parallel lines are always the same distance apart. And if line A and B are parallel, then their slope will be the same. And you can see that in this case, line A and B are parallel and they have the same steepness. Completely makes sense. If you have two lines that are perpendicular, then the two lines definitely intersect at a 90 degrees angle, so you can see that over here. And if they're perpendicular, then slope of one is a negative reciprocal of the other one. And let's label this in here. So this signifies the negative, and this signifies the reciprocal. And you can see that this makes sense because if this line over here, line B, has a positive slope, anything that's perpendicular to it will have a negative slope. And you can see if line B has a shallow slope, then line A will have a very steep slope, and that comes from the reciprocal part. Or vice versa, if line A has a very steep slope, line A will have a very shallow slope. Let's do a few examples. The first example tells us that to fill out the following table, so we're given the slope of one of the lines, and we are figuring out the slope of any line that is perpendicular to it and any line that's parallel to it. So you folks can actually try this out. You can pause the video, fill out this table, and then we'll take it up. Okay, so if the slope is 0, that means that the line automatically is a horizontal line. So a line that is perpendicular to it will then be vertical and therefore have an undefined slope. So this one over here will be undefined. If it is parallel to it, then it should have the same slope, which means that it will have a slope of 0. Now, if your slope is 1, that means the line is kind of going at a 45-degree angle. If a line is perpendicular to it, you can actually kind of see that it has the same steepness, however, it's just negative. And you can also put this into the equation. If MA is equal to 1, then MB is equal to negative 1 over MA, which means it's negative 1 over 1, which is simply negative 1. So this slope is negative 1. And if it's parallel, it will have the same steepness and the same direction, meaning that it would be 1. For the third example, if we have something with slope of 3, it's pretty steep, so a perpendicular line to it should have not as steep of a slope. We can kind of signify that here. You can kind of see it. So if MA is equal to 3, MB is equal to negative 1 over MA, which is negative 1 over 3. So this equation over here is, this slope over here is negative 1 over 3. And if it's parallel, it will pretty much have the same slope. So we can just fill that in as 3. We're kind of noticing that if the slope is something, the parallel slope is always the same because MA is equal to MB. So we can actually fill out this part of the chart very easily. So I'll do that right now. This one is negative 2, this one is 1 over 2, and this one is negative 1 over 5, and this one is undefined. Now, if our slope is negative 2, let's work in green. Then that means if MA is negative 2, MB is the negative reciprocal, so negative 1 over MA, so negative 1 over negative 2. We can see that the negatives, we have a negative divided by a negative, or we have two negatives in a fraction, which are going to make it positive. So you just get 1 over 2 as your final slope. If the slope is 1 over 2, so if MA is equal to 1 over 2, then MB is equal to negative 1 over MA, which is negative 1 over 1 over 2. And again, this is a little bit of algebra is required to solve this. I'll just do it up here. 1 divided by 1 over 2 is same as 1 times 2 over 1, which is just 2 over 1, or more simplified form is just 2. So this is same as negative, and 1 divided by 1 over 2 as we shown above is just 2. So this one would be negative 2. And an easier way to actually do this is simply to take the reciprocal of 1 over 2, which is just 2, and take its negative, which is negative 2. Alright, so now if we have MA is equal to negative 1 over 5, then MB, I'll just use the shortcut over here. We will just take the reciprocal over here, so the 1 and 5 will switch, so it will become 5 over 1. And it's the negative reciprocal, so if this one is negative, this one should be positive. So I'm just going to leave it as 5 over 1, and this simplifies to 5. And this again makes sense. This is in terms of direction, this line over here is it's negative, this one is positive, so that part makes sense. And if this one has a shallow steepness because it's a fraction, which is between 0 and 1, this one should have a steeper slope. Finally, for the last one, this is a little bit of a special case. We have a slope which is undefined, and if you recall from previous lessons, if it's an undefined slope, it means that it's infinite amount of slope or a vertical line. So if it's a line that's perpendicular to it, then it should have zero steepness. So therefore the answer to this one is just going to be 0. Okay, our next example says that line W and Z pass through the following points. Determine if they are parallel, perpendicular, or neither. So we're given some information. We are given the points that W goes through and Z goes through. And to figure out if they're parallel, perpendicular, or neither, we have to find both of the slopes and actually make a comparison. So I'm going to calculate MW over here. And I'll just label the points as x1, y1, x2, y2. And this is y2 minus y1 over x2 minus x1. And y2 is 11 minus 5 divided by x2 is 4, x1 is 2. And 11 minus 5 is 6, 4 minus 2 is 2. And this simplifies to 3. Slope of line Z, I can say slope letter M of line Z, subscript Z, is equal to, and again, it doesn't really matter how we label things, so I'll label this time as x2, y2, x1, y1. I just want to show you that it doesn't really matter how we label, we should get the same answer. So y2 minus y1 over x2 minus x1. Here y2 is 6, y1 is 1, x2 is 3, x1 is negative 7. We get 6 minus 1, which is 5, and we get 3. Negative and negative make it positive, and this becomes 5 over 10, or simplifies to 1 over 2. So in this case, we can see that MW does not equal to MZ. So we can write that MW does not equal to MZ. And we can also see that the slope 3 and 1 over 2, first of all, they're not negative of each other. And they're also not the reciprocal. So not only they're not negative, they're also not reciprocal. So we also know that MW does not equal to negative reciprocal of MZ. And since these two cases are not met, so if this one was met, that means that if MW was equal to MZ, that means that they were parallel. If this was the case, that means that they were perpendicular, but they're not any of them, so therefore the two lines are neither. So amount of work that you need to show for this, you need to make sure that you're showing that you are properly calculating the slope over here with a method mark. So one method mark here and another method mark, or more of an accuracy mark, for plugging in the proper values up here and here. Method mark for using proper equation, and finally an accuracy mark for calculating the proper slope. Same thing for the slope of Z. You got to make sure that you are using proper method and proper numbers within here. Sometimes there's an implied method mark over here. I'll include that over here as well. of actually properly making the calculations and finally arriving to the final solution is an accuracy mark. Finally, you have to make some reasoning. So there's a reasoning mark over here, and there is, in this case, there are actually two reasoning marks, one for figuring out they're not parallel or perpendicular and making an accurate final answer that the two lines are neither in this case. Now the final example says that the lines W and Z have the coordinates shown below. Determine the value of A if the lines are parallel or perpendicular. So we have to actually do two cases, one for which they are parallel and one for which they are perpendicular. In terms of the coordinate, you can see that 1, 5, 2, 7, and MZ is -2, 5, and 4, and A. And here is our missing number. This is kind of what we're trying to find. Okay, slope of W actually does not change in this case because the coordinates are already given to us. So MW is equal to delta Y over delta X. You can label X1, Y1, X2, Y2. You don't really have to show the labeling when you're writing this out, but it's just nice, especially when you're just getting started with slopes. So 7 is Y2, Y1 is 5, X2 is 2, X1 is 1. So I get 2 over 1, which just simplifies to 2. I can use the equation to also find mz, and the slope of z is equal to, again, delta y over delta x, and x1, y1, x2, y2, just labeling it up here. And I will get my y2 value is a, that's something we don't know and we're trying to find. My y1 is 5. My x2 is 4, and my x1 is -2. So I'm just going to simplify this as much as I can. I get a minus 5, and 4 minus -2 is same as saying 4 plus 2. So this will end up equaling a minus 5 over 6. Now, I don't know what a is, but I have two situations, one in which the lines are parallel, so I will do that in blue. And in this case, MW will equal to MZ. I know that MW is equal to 2, and I know that MZ is equal to a minus 5 over 6. Now, all I have to do is just solve for the a value. So to do that, I will multiply both sides by 6. And that gives me 12 is equal to a minus 5. And I will add 5 to both sides, and I will get a is equal to 17. So if, and I can just highlight that, if they are parallel, then my a value needs to be 17. Now, the second case is if the lines are perpendicular. So perpendicular lines. In this case, we know that mz needs to be a negative reciprocal of mw, meaning that what I have to do with the value or the slope of w is take the reciprocal and also its negative. So its reciprocal is 1 over 2, and its negative is just -1 over 2. Meaning that if the slope of MW is 2 over 1, then if line Z is perpendicular to it, it will have a negative reciprocal slope of it, meaning it's negative, and also its reciprocal, which is 1 over 2. Once I have this, I know that the slope needs to be negative 1 over 2, and I also know that negative 1 over 2 should equal to a minus 5 divided by 6. And now I have to solve for a. I do that by multiplying both sides by 6, and I get negative 6 over 2 is equal to a minus 5. I know that 6 over 2 simplifies to 3, so that makes my life a lot easier, and I can add 5 to both sides, and I will get a is equal to 2. And this means that the y-coordinate of this point over here, which lies on line Z, needs to have a value of 2 in order for me to get a line which is perpendicular to line W. I just want to quickly sketch these two just to give you an idea about the concepts here. And I will start doing line W, and line W, I'll do that with purple, has points 1, 5, so somewhere over here, and 2, 7, which is somewhere along here. So if I pass a line through it, it will look something like this. And for my line Z, I know that one of the points, I'll do that with blue, one of the points is negative 2, 5. So negative 2 and 5 is somewhere here. And I'm trying to find the other point which would allow me to have a parallel line first. And my x-coordinate of the point, I know that it's on 4. So I know that the x is somewhere here, and I'm trying to look for the y value. So to get a proper y value, I need the point to be somewhere here, because if it's somewhere here, then if I draw a line, you can see that you get a perpendicular line. So if I were to draw, parallel lines, and if I were to draw a parallel line, it would actually look something like this. And you can see that the coordinate y will be some large value. So it has to be definitely bigger than 5, and it will meet the x value of 4 somewhere here. And we found the a value, or the y coordinate, to be 17. So this point over here is actually 417. And if we have that point, line Z and line W will be parallel. Just going to do one other situation, which is the one in which they are perpendicular. And I'm just going to sketch out the situation. So for line W, we have one point at about 1, 5, one point about 2, 7. And if I were to draw a line that goes through them, I will kind of get something like this. And for the other one, for line Z, I know that one of the points is at negative 2, 5, which is somewhere here. And I know that my other point has x-coordinate of 4, so x-coordinate of 4 will be somewhere along this line, this dashed line. And I'm trying to find the y-coordinate of this point, so I'm trying to find the y value somewhere here, so that if I draw a line through it, it would actually be perpendicular. Now, if I were to draw a line that's perpendicular to this, it would kind of look like this, and it will go like similar to what I've drawn here. And you can see that the point here will have x coordinate of 4 and y value of a, and in this case we found out that our a value was actually 2, which in our sketch kind of makes sense. You can see that if this is 5, this is approximately 2. So we actually have drawn a really, really nice sketch over here, which signifies that if our x coordinate is 4, our y value has to be 2 in order for these two lines to be perpendicular. So perpendicular like this, because if I were to choose any other y value, let's say I had chosen 4, 5, and then if I draw that line, you could see that the lines would actually be horizontal and it would not be perpendicular to this. So this question, again, we're trying to find that a value so that the two lines are perpendicular. In terms of step, this question is much more involved than previous questions. So you would have to kind of show that you can calculate the slope here. So proper accuracy of values, and implied method mark over here, and final accuracy mark for this slope. You need to use proper method and accurate values to arrive to this solution over here, a minus 5 over 6 for m for the slope of line z. You have to divide it into two situations, parallel and perpendicular. For parallel, you need to say that mw is equal to mz, so that's a reasoning mark. You need to, or reasoning or method mark in this case, you would then have to accurately plug in the values and say that, oh, mw is 2 and mz is equal to this expression here, a minus 5 over 6. And then, so accurately have those values and then properly solve it and arrive to an accurate value of a over here. Same thing when they're perpendicular, you need to recognize that the slope of mz needs to be negative 1 over 2. You need to accurately put that into the equation, use proper method, and I would say there's an implied method mark here as well in solving everything. And you will end up getting to the a value of 2, and that would be an accuracy mark.